Several times a year in the small town of Ording, Washington, an alarm sounds across the valley, and thousands of school children stand up from their desks, form lines, and start walking. They are not walking to the gym. They are walking out of town, uphill, toward higher ground, some of them covering more than 2 miles on foot, because their teachers and their parents and the scientists watching the mountain above them all know the same number, 40 minutes. That is roughly how long Ording would have, under the worst scenario. Between the moment the sensors upstream begin screaming and the moment a wall of liquid concrete the height of a building comes down the Puyallup River Valley and erases the town. The children practice outrunning it. On foot. And here is the part that surprises almost everyone. The mountain they are practicing to escape is not Yellowstone. It is not some remote Alaskan peak. When you ask American volcano scientists which mountain in this country genuinely worries them, the one whose hazard maps they lose sleep over, the answer, again and again, is the beautiful, postcard-perfect snow-covered giant standing over Seattle and Tacoma, Mount Rainier. It is one of only 16 volcanoes on the entire planet designated a decade volcano, the international list of mountains judged most dangerous to human populations. Roughly 150,000 people in the valleys below it live directly on top of the deposits left by its past disasters, which is another way of saying the mountain has already reached their neighborhoods before, and the houses were simply built on the evidence. Today we are going to explain exactly why the experts rank a quiet, currently peaceful mountain in Washington state above every famous volcano in America, what its true weapon is, because it is not lava, and it does not even require an eruption, and what the honest picture of the risk looks like for the millions of people who can see this mountain from their kitchen windows. No guessing, no dramatizing, just the facts, the science, and the real stakes. Before we climb into it, drop a comment right now. Can you see a volcano from where you live? Rainier, Hood, Shasta, St. Helens, or anywhere else in the world? Fuji, Etna, Popocatépetl. Tell me which one and how far. Away it is, because one of the strangest facts of modern life is how many millions of people have an active volcano in their daily view and never think about it. If you want to be the first to know every time one of these systems changes, subscribe right now. It is completely free, and a thumbs up pushes this to people living in these exact valleys. Let us go for 5,000 likes. Now, to the mountain. First, let us settle the ranking question honestly, because the title of this video makes a claim, and this channel backs its claims with sources. The United States Geological Survey maintains a formal national volcanic threat assessment, a scored ranking of all 161 active volcanoes in the country, combining how hazardous each volcano is with how much sits in its way, people, aircraft, infrastructure. In the most recent assessment, 18 volcanoes score in the very highest threat category. Kilauea in Hawaii tops the raw score sheet, largely because it erupts almost constantly and destroyed hundreds of homes as recently as 2018. Mount St. Helens, which killed 57 people in 1980, ranks second. Mount Rainier ranks third. So why does this video, and why do so many volcanologists single out Rainier? Because the scoring measures threat across all categories, and Rainier dominates the category that matters most, the capacity for a single sudden event to kill tens of thousands of people. Kilauea's lava destroys property and rarely takes lives. It moves at walking pace. St. Helens already spent its most dangerous card and stands in a comparatively empty landscape. Rainier looms directly above the fourth largest metropolitan region on the west coast, and it carries a weapon the others do not. That weapon is the reason for its decade volcano designation, the reason for the sirens in the valleys, and the reason those children practice walking uphill. It is called a lahar, and if you learn one, word from this video, make it that one. A lahar is a volcanic mudflow, and the name badly undersells it. Picture a flash flood, then replace the water with a churning slurry of volcanics. Rock, ash, boulders, shattered trees, and ice, with the consistency of wet concrete, moving down a river valley at 40 to 50 miles per hour. Tens of feet deep, growing as it goes because it rips the riverbed and the banks and the bridges into itself and adds them to its mass. A lahar does not flow around obstacles, it picks them up. Houses, logging trucks, steel bridges, it follows river valleys with total commitment, which means its path is terrifyingly predictable and everything built on the valley floor is in it. And that predictability is worth pausing on because it makes lahars unique among natural disasters in a way that cuts both directions. An earthquake can strike anywhere along a fault. A tornado's path is a lottery, but a lahar coming off Mount Rainier can only go where gravity and topography send it, down the handful of river valleys that drain the mountain, along corridors that geologists have mapped foot by foot using the deposits of every past flow. The maps are not projections, they are receipts. That means With grim precision, we already know which streets, which schools, which neighborhoods a future lahar will visit decades or centuries before it arrives. The flip side is just as absolute. A few hundred feet of elevation is a complete defense. A lahar 60 feet deep in the valley cannot touch a person standing on the bluff above it, which is why the entire survival strategy for these towns compresses into 4 words: get off the floor. No shelter works, no vehicle is reliably faster than the flow plus the traffic, but a 15-minute walk uphill beats the most powerful volcanic mud flow on the continent every single time. Few disasters on Earth offer their targets a deal that clean, and that is exactly why the drills matter so much. And Mount Rainier is, by a wide margin, the most dangerous lahar factory in the United States, because it combines the 3 required ingredients more perfectly than any other mountain on the continent. Ingredient 1, height. Rainier stands 14,410 feet tall, towering more than 10,000 feet above the lowland valleys, which gives any flow off its flanks an enormous gravitational head start. Ingredient 2, ice. Rainier is the most heavily glaciated peak in the lower 48 states, wrapped in roughly a cubic mile of snow. And ice, more frozen water than every other Cascade volcano combined. Heat from an eruption, or even vigorous steam activity, can melt that armor rapidly, and meltwater plus loose volcanic debris is the recipe for a lahar. Ingredient 3, and this is the one that changes everything, rot. Rainier is old, and for hundreds of thousands of years, acidic volcanic gases and hot water have been circulating through its interior, chemically transforming hard volcanic rock into soft, crumbly, clay-rich material. Geologists call it hydrothermal alteration. In plain language, parts of the upper mountain are rotten, and weak clay, rich rock, saturated with water, sitting at a steep angle 2 miles above a populated valley, does not need an eruption to fail. It just needs to let go. If that sounds theoretical, the mountain has already shown us, twice, at full scale. Around 5,600 years ago, a huge portion of Rainier's summit and northeast flank collapsed, whether triggered by an eruption or by the failure of that rotten rock, and the result was the Osceola mudflow, one of the largest lahars ever documented on Earth. It swept down the White River Valley as a wall of debris, buried more than 200 square miles of lowland, and ran all the way to Puget Sound, filling in an arm of the sea. The towns of Enumclaw, Buckley, Auburn, and parts of the Kent Valley south of Seattle sit today on top of Osceola deposits up to 70 feet thick. The mountain lost its head doing it. Rainier was once significantly taller, and the missing summit is spread across the suburbs. Well, that is the worst case, the geological monster. But the second event is the one that should genuinely concentrate your attention because it is recent and it came without an announcement. Around the year 1502, just 5 centuries ago, a chunk of Rainier's rotten west flank failed and produced the electron mudflow, a lahar that poured down the Puyallup River Valley more than 60 feet deep at points, snapping old growth forest, and buried the exact ground where the town of Orting now stands under 15 feet or more of debris. When workers dig foundations in that valley today, they find the buried forest, sheared off stumps still rooted where the flow overran them. And here is the sentence that defines Rainier's entire risk profile. Geologists have found no convincing evidence of a significant eruption associated with the electron mudflow. As far as the record shows, the mountain was quiet. A piece of it simply fell off. No warning swarm, no ash column, no weeks of escalating signals for instruments to catch. The west flank let go on an ordinary day. And if it happened once in the last 500 years, out of the same rotten amphitheater of altered rock that still hangs there today, it can happen again. That is why Rainier is different. Almost every volcanic disaster scenario in the world begins with unrest that monitoring can catch days or weeks ahead. Rainier's signature scenario can begin with silence. Now, if you want to know what a lahar does to a town, history has unfortunately provided the definitive case, and everyone who works on Rainier carries it with them. November 13th, 1985, Nevado de Leo. Ruiz, Colombia. A relatively small eruption, minor by the standards of the mountains we cover, melted part of the volcano's ice cap. The meltwater gathered ash and debris and became lahars that raced down the river valleys in the dark. 2.5 hours later and 30 miles away, a wall of mud reached the sleeping town of Armero and removed it from the map. More than 23,000 people died in a single night, in a disaster that scientists had warned about, in hazard maps drawn months earlier that showed the flows arriving almost exactly where they did. The warnings existed. The evacuation never happened, lost in hesitation, poor communication, and the simple human refusal to believe that the quiet mountain on the horizon could reach that far. Armero is the worst volcanic disaster in the history of the Western Hemisphere, and it is Rainier's scenario transplanted. Rainier holds many times more ice than Ruiz did, stands over valleys, holding not one town, but a corridor of them: Orting, Puyallup, Sumner, Fife. The tide flats of Tacoma with its port, and the travel times from mountain to town are shorter. The United States looked hard at Armero, and to its credit, it did not shrug. Because here is the other half of the Rainier story, and it is genuinely one of the most impressive volcano defense systems on the planet. The mountain is wired. The USGS and Washington State operate a dedicated lahar detection system on Rainier, the first of its kind in the United States, now expanded to dozens of monitoring stations threaded down the highest risk drainages: the Puyallup, the Carbon, the Nisqually, the White. Seismometers listen for the unmistakable ground roar of a moving lahar. Infrasound sensors listen for its acoustic signature. Tripwires and flow sensors stand in the channels. Cameras watch the upper flanks. The moment a real flow is detected and confirmed, the system triggers sirens across the valley communities, pushes emergency alerts to phones, and starts the clock, the roughly 40 minutes to an hour that towns like Orting would have. And the communities practice against that clock for real. Orting's schools run the largest lahar evacuation drills in the country, thousands of students walking the actual routes to the actual high ground, timed. Entire towns have participated in valley-wide drills. Evacuation routes are signed along the roads like exits on a highway. It is honest to say that no other volcanic hazard zone in America takes its threat this seriously. And it is equally honest to say the system has a hard limit that everyone involved acknowledges: 40. Minutes is enough time to walk out of the inundation zone if you start immediately and you're able-bodied and you know exactly where to go. It is not much time for the elderly, for hospitals, for a valley's worth of cars funneling onto 2-lane roads, or for anyone who spends the first 10 minutes checking their phone to see if it is real. The system buys minutes. Preparation decides what those minutes are worth. So what is the mountain doing right now? Here is the honest status report, and it is calm. Mount Rainier's alert level is at normal, aviation code green. The seismic network around the mountain, one of the densest on any Cascade volcano, recorded around 130 tiny earthquakes this spring and early summer, and the largest was a magnitude 2.0, a level of background chatter that glaciated volcanoes produce constantly, from ice movement, from small rock adjustments, from the hydrothermal system breathing. No swarms beyond the ordinary, no deformation of the edifice, no changes in gas or heat that the observatory considers significant. Rainier last produced confirmed eruptive activity roughly 1,000 years ago, with some disputed reports of minor activity in the 1800s, and nothing in the current data suggests magma is on the move. So let us say it plainly, the way this channel always does. There is no evidence whatsoever that Mount Rainier is about to erupt, and anyone telling you otherwise is selling fear. But now you understand why the calm seismographs are not the whole story here, in a way that is true of almost no other volcano in America. Rainier's most likely catastrophe, the electron scenario, the spontaneous collapse of rotten rock, is precisely the one that may offer little or no seismic preamble. The quiet mountain is genuinely quiet, and the quiet, in this one specific case, is not the same thing as safe. That is not a contradiction. It is the entire reason the detection system exists, listening not for the warning before the event, but for the event itself, because with lahars, unlike eruptions, detection after launch still saves nearly everyone who acts. There is one more number that belongs in this story because it is moving in the wrong direction: the population. When the electron mudflow buried the Puyallup Valley 500 years ago, the human toll was whatever villages stood in the flow's path. Today, the valleys draining Mount Rainier are some of the fastest growing real estate in Washington state. Orting alone has multiplied several times over in a generation, subdivisions spreading across the valley floor on land that is affordable in part because it is a floodplain, and it is a floodplain because it is a lahar highway. Roughly 150,000 people now live directly on top of young lahar, deposits from this one mountain, with hundreds of thousands more in the broader zone of impact, including the port and industrial tide flats of Tacoma, built on the delta that Rainier's past flows constructed. Every year of growth adds more people to the same 40-minute clock. The scientists' hazard maps have not changed. The number of people standing on them has. Before we close, this story needs its ghost, because everything America knows about its dangerous mountains, including the entire monitoring system now wrapped around Rainier, was paid for by one morning 46 years ago, 60 miles to the south. On May 18, 1980, at 8:32 in the morning, Mount St. Helens, Rainier's smaller sibling, ended a 2-month episode of unrest with an event almost no scientist alive had witnessed. An earthquake shook loose the volcano's swollen north flank, which had been bulging outward by 5 feet per day for weeks, and the entire side of the mountain slid away in the largest landslide in recorded history. With the lid suddenly removed, the pressurized interior exploded sideways. A lateral blast that flattened 230 square miles of forest in minutes snapping old growth trees like matchsticks in a pattern you can still trace from the air today. 57 people died, including volcanologist David Johnston, who was manning an observation post thought to be safely distant, and whose final radio call, "Vancouver, Vancouver, this is it," remains the most famous sentence in American volcanology. And critically for our story, the eruption also produced exactly the hazard we have been discussing. The melted ice and shattered rock became lahars that poured down the Toutle River, destroying more than 200 homes, taking out 27 bridges, and choking the shipping channel of the Columbia River with sediment 50 miles from the mountain. St. Helens was the full catalog of Cascade volcanic hazards, performed live in front of cameras, and it changed everything. The Cascades Volcano Observatory was established in its aftermath. The science of forecasting matured on its lessons and paid its first dividend within weeks as scientists successfully anticipated several of the follow-up eruptions. The bulge taught the field to watch deformation. Johnston's death taught it humility about safe distances. The Toutle lahars taught it that the mud reaches farther than the blast. Every sensor on Rainier today is, in a very real sense, a descendant of that morning. And the comparison between the two mountains is the cleanest way to understand why Rainier now outranks its famous sibling in every scientist's private worry list. St. Helens in 1980 stood in commercial forest, and it still killed 57 people. Rainier's equivalent flanks drain into bedroom communities of the Seattle-Tacoma metropolitan area. St. Helens carried a modest ice cap. Rainier carries a cubic mile. St. Helens announced itself with 2 months of escalating earthquakes and a visible bulge. Rainier's electron scenario, as we covered, may announce itself with nothing. Same mountain range, same hazard family, and one crucial difference: the number of people standing in the runout. And since we have the map open, it is worth taking 30 seconds on the rest of the family, because Rainier is the headliner of a range, not a soloist. The Cascade volcanic arc runs from northern California to the Canadian border, the onshore signature of the same Cascadia subduction zone this channel has covered before, and it holds over a dozen potentially active volcanoes, several of them in the very highest national threat tier. Mount Hood stands directly above the outskirts of Portland, with ski areas on its flanks and a history of collapses and lahars down the Sandy River. Mount Shasta in California is one of the largest volcanoes in the range and produced a colossal ancient debris avalanche that geologists once refused to believe until St. Helens showed them the mechanism. Mount Baker steams visibly near the Canadian border and gave the region a scare with a burst of thermal unrest in 1975. And then there is the one that volcanologists mention with a particular edge in their voice, Glacier Peak. Hidden deep in the Washington wilderness, invisible from the cities, Glacier Peak has produced some of the largest and most explosive eruptions in the range's recent geological history on the scale of St. Helens, 1980 and larger, and its meltwater lahars have reached the lowlands where towns now sit along the Skagit and Stillaguamish valleys. It ranks among the very highest threat volcanoes in the nation. And for years, its monitoring network was famously thin, a handful of instruments on a mountain capable of St. Helens scale behavior, a gap the USGS has been racing to close with. New stations. The pattern across the whole range is the one this channel keeps finding everywhere on Earth. The geology is well understood, the hazard maps are drawn. The gap is coverage, funding, and public attention, and the mountains do not wait for any of the three. So let us close with what can actually be done, because information without action is just anxiety. And Rainier, more than any volcano in America, is a place where preparation measurably works. If you live in one of the river valleys below the mountain, learn today whether your home, your work, and your children's school are inside the mapped lahar zone. The maps are public and free from the USGS and Pierce County. If you are in the zone, know your walking route to high ground, actually walker. And once with your family and understand the golden rule of lahars, you do not need to outrun the flow. You need to get out of the valley floor. And in most of these towns, high ground is minutes away on foot. Sign up for the county emergency alerts. Keep your phone's emergency notifications on, and when the sirens sound, move first and verify later, because the entire lesson of Armero, purchased with 23,000 lives, is that the people who moved immediately lived. Keep the basic kit, water, medications, shoes by the bed, because a valley evacuation at 3 in the morning is a very different event in boots than in socks. And if you live anywhere else in volcano country, the Rainier playbook travels: know your hazard, know your route, trust the sirens. Here's the final thought. Mount Rainier is, by any measure, one of the most beautiful mountains on Earth, and that beauty is not incidental to the danger. It is the same fact. The height that fills postcards is gravitational energy. The glaciers that glow at sunset are a cubic mile of stored floodwater. The valleys that make such perfect towns are perfect because the mountain graded them with flows exactly like the ones the maps now warn about. The people of Ording are not foolish for living there, any more than the people of Tokyo or Naples or Memphis are. They live, like most of humanity, on ground shaped by the very forces that threaten it. What sets the Rainier Valleys apart, and what makes this story quietly hopeful, is that they have chosen to know it. The sensors listen. The sirens stand ready. The children practice walking uphill, and every drill is a bet that when the mountain finally does what mountains do, this generation, unlike our Marrows, will already be moving. The mountain holds the power. The valley holds the clock. And the clock, for once, has been given to the people. We will keep watching Rainier and every very high threat volcano on the national list, every swarm, every study, every upgrade to the warning systems, and if anything genuinely changes on this mountain, you will hear it here first with the data, not the drama. Subscribe so you do not miss it, and leave that comment below. Can you see a volcano from your window, and do you know if you are in its hazard zone? Tell me your story, because these are not just geological events, they are human experiences, and understanding that is how we stay motivated to take this seriously.